So let's imagine that you are a lifeguard and you've got a beach here and you've got to protect that swimming beach with a rope that have got buoys attached to it. So these are the buoys. And you want to find the maximum area that you can with the rope that you've got, or the rope with the buoys on it. So there are a couple of things that you need to know before you even start, and one is that you need to know the length of the rope. So let's say the length of the rope is 200 meters, and the diagram I've given gives you kind of an indication of where we're going to put our variables. So I'm going to put one variable here, that's x, and that's y, and that would be x. So I want to enclose the largest area. So that if this is an optimization problem, you want to maximize something, and you need to find an equation for the variable you want to maximize. So I want to maximize area. That means I need a formula for area. So area is length times width, which in this case would be x times y. And I've got three variables there, a, x, and y, and I would like to reduce that to two variables. So I am going to use this information right here, which is the length. The total length of rope is 200. So that means that 2x plus y equals 200. So I can isolate y quite simply. So I move the 2x over to the other side, subtract 2x from both sides, so I get 200 minus 2x, and I allow that to be substituted into this equation here. And that allows me to write it as with just the x as the one variable instead of x and y. I'm going to multiply this out. 200x minus 2x squared. Now it's really tempting to just take the derivative with respect to time, but remember, we just even though we just finished related rates doesn't mean that everything is a related rates question. In this question, we want to find the maximum, so we want to take the derivative with respect to x. So I'm going to take the derivative with respect to x, so I might need a little bit more room. I'll put it in here. So that's dA by dx. I'll take the derivative of this expression right here, which is 200 minus 4x. And what I want to know is, where is that a maximum? I could do the first derivative test or the second derivative test, but what I'm going to do is figure out where the critical points are to start with. So where is this equal to 0? So where is negative 4x equal to negative 200? That means where is x equal to when x equals 50. So it's going to switch at x equals 50. And if I did the number line method, which I know you guys have practiced a lot by now, so if you go when x is 50 and I figure out what's happening to 200 minus 4x, it's going to be negative on this side and positive on this side. So that means I'm increasing this side, decreasing here, and that means there's going to be a local max. Is it the absolute max? Well, we have to make sure we test the endpoints. And the smallest x value that I could possibly have is 0. So the endpoints are 0, and I'm going to now need a new page. So I'm going to test my endpoints, which is 0, and the largest would be let me think about what was the length of the rope again. I got to go back. I guess I've got a short memory. The length of the rope is 200. So that means that the maximum, I didn't go back here. There we go. The length of the rope is 200. So that means that if I have a very small y, nearly 0, that means the x's would each have to be very close to 100 each. It would be a very long, skinny, well, it would be infinitely small, but if this was infinitely small, then these would have to be approach 100 each. So that means my endpoints, oops, I'm moving in the wrong direction here. My endpoints are 0 and 100, and then I've also got my a critical point, which is at x equals 50. And if I plug that into my area function, I want to find the maximum area. So it shouldn't actually be y, because I've let y be something else. I want to calculate the area. So the area when x is 0 is 0, and when x is 100 is, I'll just write the area function again here just so we don't lose it. Where is it? 200x minus 2x squared. 200x minus 2x squared. So if I plug in my 100, I get a 2000 here minus 2000, which is 0. That makes sense because y is infinitely small. And when I have area is 50, plug in my 50, and that gives me 5,000. So the maximum area is 5,000 square meters, and it happens when x is 50.